Bismillahirrahmanirrahim. Let's have a discussion on the fourth radioactive decay, which is called the electron capture. And the objective over here is if a nuclide is radioactive, and that means it is unstable and there is no emission of the alpha radiation, positron, or the negatron. Then what would be the other option for the nuclide to get itself stabilized? So there is the fourth one option, that is called the electron capture. So what is the electron capture, or we call it the K electron capture? Because here the nucleus is going to capture the electron from the K shell. That's why this is called the K electron capture. And in this process, electron is captured from the innermost shell, that is called the K shell, and simultaneously it is the emission of the neutrino and producing an overall effect similar to the positron emission. So again, look at the very simple equation over here. What we have written over here, what are the changes are being happened in case of the electron capture. So similar to the positron emission, again in positron emission, protons are converted into the neutron. You can remember by the sound over here. And in electron capture, the same process is happening over here. Protons are converted into the neutron plus the emission of the neutrino. And this is similar to the effect of the positron emission as well. But here there is no emission of the positron, but this electron is captured by the nucleus, and because the nucleus is having the protons which are having the positive charge, so they will capture the electron from the K shell, and when it's captured the electron, it is converted into the neutron. So what would be the effect on the atomic number and the mass number? Look at the values over here. There is no change in the mass number, but there is decrease in one atomic number. So similar to the positron emission, this is happening over here, but the difference is there is no emission of the positron, but this is the electron capture. Later on, we will also compare the positron and the electron capture at the last slide. So let's suppose this is an example. Copper is capturing the electron from its nucleus and then converted in the nickel plus producing the X-rays. So this X-ray is associated with the electron capture. Again, I am going to describe how these X-rays are going to be generated with the emission of, or with the process of the electron capture. So what important over here is with the electron capture, there is same mass number and there is decrease in one atomic number. So that is in case of the electron capture and plus producing the X-ray. So the third one is the, as we have done the calculation for the energy release in during the decay process, so you can also calculate the energy release during the electron capture, and this is the very simple formula again. This is the parent is having the mass of Z, and this is going to be daughter having mass 1 less than as compared to the parent. So you just put the masses of the parent and the daughter over here, and then you just multiply by the factor 931.5. That will directly convert into the energy in mega electron volt. So you can also calculate the energy release in electron capture by using this equation. So note down, this equation is different from the positron emission, and this the way of the expression is also different from the positron emission. The only similarity is there is the decrease in atomic number in both of the cases. So now moving to the processes which are associated with the X-rays are with the electron capture, or the X-rays and the Auger effect. So what is happening over here? This is the nucleus. Nucleus is having the protons and the neutron, and this one proton, if it is capture one electron, and the easily access of the electron is from the K shell. So that's why this is also called the K electron capture. So if it is capture one electron, so what is the as phenomena is being happened over here? There is the in vacancy that is created in the K shell, and of course, if this vacancy is created and there are the electrons which are present in the L shell, they have the ability to move towards the K shell. So this is the energy of the K shell, and by using the simple equation, you can calculate the phone or the quanta of light over here, the energy associated with this shell, and then this is the E1 energy of the one shell that is in the K shell, and this is the energy in the L shell, or you can say this is the E2 energy at the second shell. So if this electron is going to move towards the K shell, that means electron present in the L shell are having more energy as compared to the K shell. So the energy is released while moving the electron from L shell to the K shell. So when this electron is moved to fill the vacancy created in the K shell, and then the rest of the energy or the excess of energy is released, and you can calculate the difference in energy between E2 and the E1. That is called the X-rays. So it is not having any significant name over here. That's why this is called the X-rays. So this is the first phenomena that is associated with the electron capture, and this is the generation of the X-ray, and you call the X-ray emission. Now, what is the Auger effect or the Auger electron? Now look at the vacancy created in the L shell. So now the vacancy is created in the L shell because this electron has already moved to the K shell, and this vacancy is created, and to fulfill this vacancy, electrons from the M shell is going to move towards the L shell. So again, this electron which is going to move from the M shell to fill the vacancy created in the L shell, that is called the Auger electron, and this effect is called the Auger effect. So again, there is a difference in energy released during the Auger effect. So these are the two effects or the processes which are associated with the electron capture. And so here there is an exercise in the similar way we have discussed before in the other decay process. So if this is the potassium with the electron capture, capturing the electron from the inner shells, that means from the K shell, then what would be the daughter nuclide over here? This is the parent. After capturing the electron, it is converted into the daughter, and your answer is this is the argon having the atomic number of 18, because in electron capture there is decrease in the one atomic number and there is no change in the mass number. So this is the electron capture. Now, what is the main difference between the electron capture and the positron emission? So I have shown you over here the different way to have the differentiation between the electron capture and the positron emission. So first look at the equations. In the both cases, protons are converted in the neutrons. There is a decrease in one atomic number. There is decrease in a one atomic number. The difference over here is this is the electron capture. It is emitting the beta positive or the positron emission. And this is the again similarity. It is also emitting the neutrino. This is also emitting the neutrino. What is over here? With the electron capture, you will get the X-rays. With the positron emission, you would get the positron emission over here. And again, There are the other processes which are associated with the positron emission, and for this you have to watch that video again. So what would be the equations? Look at the equation. This is the uh, atomic number of the parent having less atomic number, one atomic number less as compared to the parent in daughter, plus neutrino plus q value. But here this is also the similar equation, but you have the positron over here for the positron emission, and but the change in the atomic number and mass number having the same in both of the cases. This is the equation. Energy release, this is the big difference between the electron capture and the positron emission. You can calculate the difference between the daughter, sorry, the parent and the daughter, and then you can multiply 931.5 to convert this mass difference into energy released during the electron capture process. But here one additional factor is given over here. That means you have to subtract the mass of two electrons which are being emitted during the positron emission, and that process is called the annihilation process, and I have already described during the positron emission. So this is all about the difference between the electron capture and the positron emission.